Okay, guys. Um, I'm going to go over the problems on the back of the reperformance packet. I've had a couple of people ask me, and so I just want to make sure we take some time to review how we evaluate integrals from graphs. This first one starts with this equation that may be kind of hard for you to read. It says g of x equals the integral from 2 to x of f of t dt. That means that for any value of x on this graph, any number that's sitting here, I can find the value of the function g of x by looking at the graph and determining the difference in area from 2 to whatever point that is. And there's two of these for us to figure out. Basically what it's telling us is that this graph f is the derivative of g, and so in order to evaluate any g value, I base it on the amount of area that is between the point where x equals 2 and that number on the graph. So our first one says g of 8. I'm just going to rewrite my integral and say g of 8 is equal to the integral from 2 to 8 of f of t dt. So that means here's 2, here's 8. I'm looking at this area. So there is a triangle above the x-axis, and then there is a smaller triangle below the x-axis. And I just need to combine those areas together. This first triangle right here, it is and again, I'm going from 2 to 8. So we're just going straight ahead on this. The first triangle has triangles 1/2. The base goes from 2 to 6, so it has a base of 4. The height of it, and they told us right here that this is at 4, 4. The height of that triangle is also 4. So that's this triangle right here, its area. I'm going to add to that the area of this triangle. We're only going up to 8, so it's only half the triangle. So it is 1/2. The base of this triangle is 2, but this one is going below the x-axis. So instead of including a 4 for the height of this, I'm going to put in its height as a -4, because the area above the x-axis counts positive, below the x-axis counts negative. So if I evaluate this, I have half of 16, so I have a +8. And then I am adding in half of a -8, which is a -4. So this 8 represents the area of this triangle. This -4 is the area of this triangle that's below the x-axis, and that integral is 4. So my value over here for g of 8, it's equal to 4. Now if I look at the next one, it says g of -2. Let's do that one in a different color. So g of -2, I'm going to start out the same way. G of -2 is equal to the integral from 2 to -2 of f of t dt. Now, first thing I notice on this is that my boundaries are backwards. We're always supposed to integrate from low to high. And so because these are backwards, I'm going to rewrite this as the opposite of the integral from -2 to 2 of f of t dt. So now when I look up at my graph, I am really just looking at here's -2, here's +2, and I'm trying to evaluate that area. Again, it's above the x-axis. This triangle is the same height as this triangle was right here. So I'm going to evaluate this. This negative sign, I'm just going to leave that negative sign sitting out in front. Find the area of this triangle. Just like the one we did in the last problem, 1/2, the base is 4 units from -2 to 2, the height is 4 units, and I have -8 as the value of that integral. It is negative because in essence, we were finding area from 2 backwards to -2. And so that kind of inverts the area and makes it negative. Question number 3 is asking us a different question. It says, what is g prime of 4? What's the derivative of g at 4? Well, remember that I said before, if I'm integrating this to figure out what g is, that means the graph that I'm looking at is the derivative of g. So when it asks me for g prime of 4, that is the same thing as asking me for f of 4. So the value of g prime is going to be equal to the value that this function takes on when x equals 4. So I look right here at x equals 4. Again, that's the point 4, 4. Since this function f has a value of 4 when x equals 4, this is just equal to 4. So again, if I integrated f to get it to be g, that means f is the derivative of g. And so when they ask me for a value for g prime, it's just the value of the graph that I'm looking at. Okay, so if we jump down then to the next set of problems, I have this little curvy graph. It tells me this is the graph of f prime, and a twice differentiable function on the interval from -3 to 4. The graph of f prime has horizontal tangents at 1, or -1, 1, and 3, which we don't need for this. The areas of the regions bounded by the x-axis in the graph of f prime are 9 and 12 respectively. Now they are below the x-axis, so we have to take that into account when we're evaluating these. Now it says given that f of 1 equals 3. That's an important point because that means that puts this point right here as kind of our anchor value. And I know that the function f is equal to 3 here, and I can figure out all the other values just by adding or subtracting whatever area has accumulated. So I could rewrite this equation kind of how we started with an integral before, that any particular value of x that f takes on is going to be equal to the value that it takes on at 1 plus the area from 1 to x. So this is where the x shows up. Why am I using 1? Because that's the point they told me. If I integrate from 1 to any x value of that derivative graph that I see and add that to the 3, that's what's going to give me a value for the function. So it's going to look like 3 plus the integral from 1 to x of f prime of t dt. And that's going to give me a value for the function. So first one says find f of 4. F of 4 is going to be equal to, and again, I'm just going to use this equation. It's 3 plus the integral from 1 to 4 of f prime of t dt. So area from 1 to 4, I see it right here. Here's 1 to 4. It's 12, but it's below the x-axis, isn't it? So that means that I'm going to take that 3 and I'm going to add the area between 1 and 4. In this case, it's negative because it's below the x-axis. I have 3 minus 12. The answer to this one is going to be a -9. If I do the same process for f at, what's the other one? Oh, -2. That's going to be 3 plus the integral from 1 to -2 of f prime of t dt. Again, notice that this is upside down, so it's going to be 3 minus the integral from -2 to 1 of f prime of t dt. So I've just inverted the boundaries and changed my plus to a minus. Now go back to my graph, and what do I see? I see that from -2 to 1, it told me that my area was 9. It's below the x-axis. So this is 3 minus the area between -2 and 1, which is a -9, and 3 minus a -9 is going to be equal to 12. So f at -2 is equal to 12. So this is kind of the two different ways that we can see this problem. The first one where they're just asking us to evaluate based on a given integral. And this other one where we're still integrating, but they tell us that function takes on a particular value at a point. And so I'm going to add the amount that's accumulated. Again, always keeping track of when it's below the x-axis, the area becomes negative. Anytime that I have boundaries that are from high to low instead of low to high, I switch them and put a negative sign in there. So we do kind of have to keep track of our positive and negatives. So that's just a quick review of the practice with graphs problem. Make sure that you understand this before you turn in those problems, because this will be on our test. All right, thanks guys. I will talk to you later.